Okay, we are in section 4.3 of trigonometry. And this stuff is very slow go here. So you're going to have to stop your video many times. I'll try to talk slow. This is going to be a long video, I think. It's the graphs of tangent, cosecant, secant, tangent, and cotangent. This is not easy to do, okay? So the good thing is it's a little bit of a review of sine and cosine at the beginning, okay? So what we're going to do on this is, if you recall, and this is really important, the basic sine graph, right, starts at the midline, goes to its max, down to its midline, then to its minimum, and then to its midline. So it looks like this, okay? That is going to be the beginning of the cosecant graph. That's going to be the beginning of it. What you're going to do is, the procedure, as you can see, is construct the sine of the cosine curve. All right, fine. Then you're going to do the asymptotes, which are based on midlines. What is an asymptote? An asymptote is when the value of the function is undefined. Okay, and it's undefined when the denominator is 0. And that happens when you start doing reciprocals. Okay, so I'm going to draw this asymptote, and this asymptote. They all happen when you hit the midline. Okay, now this actually isn't the graph of cosecant. That's really the apparatus, or that's the structure of it, or the scaffold of it, okay? The actual graph is right here. It's going to be a parabola that hits that vertex and goes right there. And of course, it continues on and on and on. But that's the basis of it. If you can graph sine, you're going to be able to graph cosecant, no problem. Okay? Now, cosine, of course, starts at its midline, or starts at its high point, then goes to the midline, then the minimum, then back to the midline, and then the maximum. So it looks like this. Okay? So in this particular case, the asymptotes are going to be right along the midline, right there and right there. Okay, again, that's not really the graph, that's the scaffold of it, because we're doing the reciprocal, and the reciprocal is going to be this parabola, which gets really close. It starts gradually getting closer and closer to the asymptote, but of course never touches it because you'll be undefined there. Okay, couple reminders, very important. In my system, 4 boxes equals 2 pi. Therefore, 2 boxes, and you might want to write this down somewhere on the side. 2 boxes equals pi, and 1 box equals pi over 2. I would write that down somewhere. Maybe you put it up here. My pen's a little thick, so I can't quite get it in there. Okay? Now, tangent has a different period involved. Okay? Tangent's period is pi. The reason for that is, and I'm going to draw it right here, is the unit circle. If you remember, tangent repeats itself every 180 degrees. Tangent is positive here, negative here, positive in the 3rd quadrant, and negative in the 4th quadrant. So again, I'll change color so you can see it. As you move around this circle, at this point, tangent's going to repeat itself. It's only every pi, not 2 pi like sine and cosine. Okay, so this one has a different period. Okay, all right, fine. So your basic graph for tangent will start in the middle here, and because the period is pi, that's 2 boxes, as I've seen, you see there. And so I'm going to go 1 box on each side for my asymptotes, and I can do that continually if I want. Okay, then right in the middle, I'm going to put that as the turning point, And tangent is, positive tangent is high on the right and low on the left. High on the right and low on the left. High on the right and low on the left. It doesn't really have an amplitude. It doesn't have an amplitude. It doesn't have an amplitude. So that's tangent. Cotangent is exactly the same thing. Okay. Again, if I start there, the period is pi, which is, I'm going to cut that in half. So I have a box on each side, which totals pi. And then I can do that continually if I want to and go on forever. Okay. How many you draw is kind of up to you. I don't really care. But you know, cotangent, high on the left, low on the right. High on the left, low on the right, with a little swoopy turn in there. Okay, low on the right. Okay, that's cotangent. All right, that's the basic graph. Now I'm going to go ahead and clear this and let you write some of the other notes down here. I'm going to slide down a little bit. You're going to see a bunch of extra information. I'm not going to go over all this in this video. I think that's something I'll handle in class. Right now, my only goal in this video, is to get you to graph these correctly. So go ahead and pause this and just get that information down. But this is something that I probably won't even test on. I'm going to be introducing that in class. It's not worth the time on the video. Okay. And again, the goal of the video is to learn how to graph these using my system. Okay. Okay. So let's slide down here. And I'm going to flip over to my blank one. I think this is going to be better on a blank one than it is like I've done in previous videos with the actual answer key. I think it'll be better here because I can change colors and do some cool things. All right. So cosecant, the first one. The first one you're doing here, you are thinking sine. That's what you're thinking. I'm thinking sine. Okay. And it's negative sine. So that one is going to look like this, if you recall. Okay. Mid, low point, mid, high point, mid. Okay. The amplitude, this doesn't really have an amplitude, but what I'm going to do first is I'm going to draw the sine graph as the structure. So I'll go ahead and list it. The amplitude is 1. Okay. The period on this is going to be 2 pi. Again, it's 2 pi divided by that number right there, which is 1. The shift on this is going to be, you're going to go pi to the right, which is 2 boxes, right? Remember, that's 2 boxes, okay? And then the vertical shift is going to be going up 2. All right, fine. So here's my midline right here, okay? And then my amplitude's 1, so I'm going to go 1 on each side of it. Great. And the starting point, instead of on the at the y-axis, I'm going to go pi to the right, and pi is 2 boxes. So I'm starting right here. Okay, I'm starting right there. Okay. And since the period is 2 pi and 2 pi is 4 boxes, I'm going to count 4. 1, 2, 3, 4 right there. So I'm going to do my 5 marks right there. Okay. So it's going to look like this if you remember this. So it starts right here, goes to its low point, back to the mid, up to its high point, back to its mid. Okay, like that, right? I'm going to draw the asymptotes. Those are going to be every single time it hits the midline. All right. Now, that actually isn't the graph. That's the structure or the scaffold for the graph. The graph is here in pink or whatever color this is, okay? It's the 2 parabolas right there, okay? There it is. Okay, great. Next one, okay? Next one, on this one, the amplitude is 3 for it's actually 3 for the structure. We're actually not, like I said before, it doesn't really have an amplitude, but just for the scaffold, it's 3. Period is still 2 pi, if you recall. 2 pi divided by that 1 is still 2 pi. The horizontal shift is going to be, it's going to go to the left pi over 2, which is 1 box, 1 box, correct? Okay. And again, it's negatives. The shift is to the left because it's the opposite of the positive number. And then the vertical shift is down 1. Okay, so I'm starting down here, down 1. Okay. And amplitude's 3. 1, 2, 3. Up there is the high point. 1, 2, 3 is the low point right there. Okay. Now, where am I starting? I'm starting right here. I shifted 1 box to the left, and my period is still 2 pi, which is 4 boxes. 1, 2, 3, 4. Okay. And this is the inverse of cosine. Cosine starts at its high point, goes to the midpoint, down to the minimum, back to the midpoint, up to the high point. Okay, so here we go. Starting at the high point, down to the midline, down to the minimum, up to the midline, got it to the maximum. All right, there we go. It's drawing like this. And of course it goes on forever and ever. Oops, I missed that. Goes on forever and ever. Okay, but I'm just going to draw the one thing there. Okay, and then of course when it hits the midline, these are your asymptotes right there. Okay. All right. Now I only have room the way I do this for one of the parabolas. It's right down here. Okay. It goes on forever and ever, but just the way I did it, I only have room for one down there. You're going to notice that the secant is going to have one parabola the way I do it, and the cosecant is going to have 2. But of course, it goes on forever. And you can check the answer key notes online if you want to see the full scale of it. Okay. Next one's tangent here. Tangent. Okay. Remember, it doesn't have an amplitude. We're not even going to talk about the amplitude. It doesn't really have it. Just there's no such thing on that. Okay. The period on this is going to be pi, because it's just pi divided by that number, which is a 1 right there. Remember, tangent repeats itself every 180 degrees, which is pi. All right. Because we know that tangent is positive in the first and third quadrants. It's a repeat where both are positive or both are negative. So that in the tangent is y over x. So therefore it ends up repeating itself. Okay. The horizontal shift on this is going to be pi over 2 to the right, because this is negative and it acts in the opposite manner. Vertical shift is down 3. All right. So I'm going to go 1, 2, 3. I'm going down 3. Down 3. Okay. Now, what I'm going to do is the starting point's usually here, but I'm going to shift 1 box to the right there. Okay, this is my starting point. So right there is going to be the dot for the turning point of this function. Now, since the period's pi, I got to cut this in half and have pi over 2 on each side. And pi over 2 is 1 box. So you see that distance between the 2 blue lines that are vertical there is pi. Okay. And if I wanted to draw more, I could. It's very easy to draw more of these. It's not difficult to do. Just put a dot in the middle. And tangent is positive tangent, high on the right, and then low on the left. So it goes boom, boom. Okay. Okay, so it starts up here and then whoosh, boom, starts up here and goes boom. Maybe I should have switched colors on that. In fact, let me go ahead and do that just to emphasize that this is the actual drawing. Everything else is the scaffold for it, support pieces. Okay. And again, the goal of this particular video is to get you to draw these, not to know every single detail of why and how, but just to kind of get it drawn. That's the goal of this particular video. Okay. All right. Awesome. So if you need to stop the video right there and pause and write some stuff down, fantastic. Okay. Now let's go down to the next set. I think I got 9. I got a bunch more here, which is good. So we can really hammer this out. Okay. Next set. All right. So here's a cotangent guy again. Okay. And this is negative cotangent. So it's going to act like tangent in terms of the drawing. Okay. Amplitude is, we're not going to be even talking in terms of that. So that's none there. Okay. The period on this will be, I think it's still pi. We're still doing pi there because that's a pi divided by 1, which is still pi. The horizontal shift is going to go to the left pi. Again, it's going to go opposite of that positive sign. Okay. And then the vertical shift is up 3. So 1, 2, 3. So there's my midline of this function. Okay. Now I normally start here, but I'm going to shift it to the left pi. And if you recall, pi is 2 boxes. So I'm going to start here. Okay. So there's my point right there. And then because the period is pi, I'm going to go 1 box on each side because 1 box is pi over 2, and 1 box on each side makes pi. Okay. And then I'm going to do that. And you can make as many as you want. Okay. Negative cotangent is going to function kind of like it's going to function like a tangent line in terms of the drawing. That's what it'll look like anyways. Okay, so I'm going to go up here and go like that. Do you have to do 3 of them? No. I mean, it's kind of cool to do a couple of them. It's really easy to do. So that's what I like about it. Okay. Next, we got a cosecant. So we're thinking sine here. And this is positive. So sine has this shape. The scaffold's going to look like that. There's your midline. Okay. So in this case, I'm going to have an amplitude for the scaffold, not, of course, for the actual problem, but we're just going to go ahead and write that, a half. The period in this case is going to be, the period will be, I got to do some factoring real quick here. This is 2 times x minus pi over 2. And if you're not sure about that, go ahead and multiply the 2 back through. 2 times x is 2x. 2 times pi over 2 is pi. So we got it, okay? So the period on this is going to be pi because I'm going to divide 2 pi divided by 2, which is pi, all right? The horizontal shift is going to be pi over 2, and I'm going to go to the right. It's going to go opposite that negative sign. And the vertical shift will be up, I guess, 1. Okay, so here we go. Draw that. I like using different colored pencils. You probably should too. It's kind of cool to do it that way. All right, so go up 1, and then let's see here. The amplitude, the amplitude's a half. Wow, so I got to kind of squeeze that in there, right there and right there. Okay. And normally we start here, but we're going to shift over 1 box, which is pi over 2. Okay, 1 box here. And our period is going to be pi, and pi is 2 boxes. Remember, 2 pi is 4 boxes. So I got to get 5 marks in a real small spot, and it's got to be this shape, the one I'm circling. Okay, so I'm going to start at the midline, go to the max, back to the midline, go to the minimum, back to the midline, and there we go. Okay, now every time it crosses that midline, I have an asymptote where the value is undefined, okay? And again, that's not actually the graph, that's the support of the graph. So here ends up being the graph, that's a parabola in there, believe it or not, and that's a parabola. Got to squeeze that in there, okay? It's a pretty bad looking parabola. Okay, got it. And of course it goes on and on and on. You could go to the right and the left of that and continue going, okay? All right. And the final one there of this particular set, anyways, not the final one of the graph of the page. Amplitude's 3 on this, and again, we're thinking sine here. We're thinking sine. Now, this is going to be a reflection on this sine, so it's going to look like that. Okay. Okay. So we're thinking sine. The period on this, I got to do some factoring real quick here. I will write that right here. It's going to be 1/2 times x plus 2 pi, correct? Right, x plus 2 pi. If I'm not sure about that, I'm going to multiply it back through. 1/2 times x is x over 2. and a half times 2 pi is pi. Awesome. So we got it. So the amplitude's 3. I got that. The period on this is going to be 4 pi. Wow. 4 pi is 8 boxes, right, in my system. 8 boxes. Okay. And I got that by going 2 pi divided by 1/2, if you recall that from previous lessons. The horizontal shift will be 2 pi, and I'm going left, okay? And then the vertical shift is, I don't have one. So this starts right here, awesome, okay? So instead of starting here, I'm gonna shift 2 pi, which is 4 boxes. 1, 2, 3, 4, I'm starting right there, okay? Now, as I go, I'm gonna go 4 pi, and 4 pi is 8 boxes. So that's 4, 5, 6, 7, 8 right there. And so I got to put my marks in those 5 spots. Okay. And the shape, let me get a different color pen out real quick to see the shape because it's buried in here. The shape is going to look like this, if you recall. That's the negative sign where it's the reflection. All right. So it starts. Oh, I did forget the amplitude, so I will get that real quick. The amplitude, we have 3 and 1, 2, -3. Okay. So this will start at its midpoint for sine. It will go to its low point because it's a reflection being negative, back to its midpoint, up to its maximum, and then down to its midpoint. All right. And again, I'm going to, at the midlines, I'm going to put those asymptotes right there. Kind of missed that one. And now the graph, which I'll do in that hot pink that I got here, is actually this. Okay. So again, pause the video here if you need to. But if you have mastered section 4.1 and 4.2, this is not going to be a problem. The only thing really new will be the tangent and cotangent. Okay. So pause it if you need to, because I'm going to erase it. Okay. Now we're going to slide up here and do 2G and just a little bit, right? That's good enough. Okay. We're going to do 2G. Okay. On this one, again, we got a negative tangent. So negative tangent's gonna act like a cotangent there. Okay. So, all right. So what we got here on 2G is we don't have an amplitude. We don't even talk about that. There just isn't one that we have, not even on the scaffold. The period is it's going to be 2 pi. Now, how did I get that? That is pi divided by a half, because this could be rewritten negative tangent 1/2 x minus 2. And remember, the period of tangent is pi. And then if I want to adjust it because of the b value, I'm going to divide by a half, and I got 2 pi. 2 pi is 4 boxes. Okay. The horizontal shift, there isn't one in this case. We got a break on that one. And the vertical shift is going to be down a couple. All right, down 2. So there's the midline of this situation. And we're going to go ahead and start here. And we know in this case that the period's 2 pi. 2 pi is 4 boxes. So I'm going to go 2 boxes on each side. Okay. Whoops. I don't want that middle line there. Let me erase that. Teacher error. Okay. So I'm erasing too much now. What is going on? Okay, so -2. There we go. Okay, so I'm going to start right in the middle there. Okay, now if I want to extend this 4 boxes, 1, 2, 3, 4 on each side, I can. 1, 2, 3, 4 on each side. It kind of looks cool if you do that. And since this is negative tangent, it's going to go up on the left, down on the right. Okay, and again, I should probably switch colors on that because really that is the graph. This is actually the graph. The other part is support pieces. which everybody draws them anyways because you want to see those support pieces. Okay? All right. Now, of course, these next 5 are going to get pretty wild here, but let's give them a shot here. And again, take your time. If you have to stop and look at it, go ahead. If you got to use your book at the same time, that's fine. That's what this is for. Okay? So on H here, again, we don't talk about anything in terms of amplitude, so that we don't have that. Okay, we don't really do that. But for the scaffold, of course, we're going to say it's 2. Okay, and we are thinking cosine here, right? And we're thinking negative cosine, which starts at its minimum and goes to the midline like that. Okay, so again, you know the shape of it. It's really going to help you. Now, I'm going to need to rework this a little bit, okay? So I'm going to write that right here. Negative 2 secant, and then I'm going to take a half out of this. Wow, this is going to be really tricky. And this is going to be x plus 3 pi. Now, and then minus 1. Now, if I'm not sure about that, this is SEC secant. If I'm not sure about that, see my cursor here, multiply 1/2 times x, that's x over 2, and 1/2 times 3 pi, that's 3 pi over 2. Okay, we got it. Okay, so on this, the period is going to be 4 pi. How did I get that? That's 2 pi divided by 1/2, that b term right there, which you've learned in previous lessons. 4 pi is 8 boxes. This is going to be really big, okay? Hopefully I can fit on here. The horizontal shift will be 3 pi to the left because it's going to be opposite that positive 3 pi. And the vertical shift looks like it's down 1, negative 1. All right, so negative 1's right there. Great. Normally I start here, but I'm going to move this thing 3 pi. Well, if 2 pi is 4 boxes, then 3 pi is 6 boxes. So I'm going to go 1, 2, 3, 4, 5, 6. This is my starting point. And my period is 4 pi. And again, 4 pi is 8 boxes. So that's 6, 7, 8 goes right here. So cut this in half. 1, 2, 3, 4. Okay, those are my tick marks. Those are my points that I'm going to be establishing. I got to get the amplitude for the scaffold, which is 2, right? And remember, this is a negative secant. So it's the inverse of the cosine for the scaffold, okay? And the inverse of the cosine starts at its minimum, goes to the midline, up to the max, down to the midline, down to the minimum, okay? And it's looking something like this, right? And at the midline, I am doing my asymptotes. And so we're only going to get one parabola in, but of course it continues, you know that. So again, changing colors to that pink, that is the actual graph right there. Wow, that's a lot of work. The good thing is you're reviewing cosine as well. That's the good news. Now the next one, I'm going to have to do some erasing here because I'm not going to be able to fit all that in. Okay, so the next one, let me move my mug out of the way. Okay. Okay, the next one, again, amplitude for something like cotangent, there's none, okay? Now, so I got to do some reworking of this. 3 cotangent 1/2, 3 cotangent 1/2 x plus 2 pi plus 2. If you're not sure about it, take 1/2, multiply it by x, and indeed you get x over 2. Take 1/2 and multiply it by 2 pi, and indeed you get pi. Great, okay? So the The vertical shift is 2, okay? The period on this is going to be 2 pi. How did I get 2 pi? Remember, for the period, P equals, it's going to be pi for tangent cotangent divided by a half. And that's going to be 2 pi. And then the horizontal shift is going to be 2 pi to the left. 2 pi to the left. And remember, 2 pi is 4 boxes in my system. Okay? So let's do this. So let's shift this 4 boxes. 1, 2, 3, 4. And the midline, the vertical is right here is 2. So 1, 2, 3, 4, right there is going to be the turning point of this. Now, the period's 2 pi. 2 pi is 4 boxes. Okay, so I got to go 2 boxes on each side to establish that period. Okay, now I can do this multiple other times, of course. I can go, 4 boxes. I'll just do 2 of them this time, okay? Great. Now, I'm going to do cotangent. And cotangent, positive cotangent, high on the left, low on the right. Okay, there you go. Again, pause that if you need to. Fantastic. All right, 3 more to go. 3 more to go on this. Probably good right there. Okay, so on this one, we got a secant problem. And when you're doing secant, you are thinking cosine. You're thinking cosine, okay? So on this one, the amplitude of the scaffold is going to be 1. By the way, I better rework this. Secant 2. Let me erase it. That is really bad writing. Secant 2 times x plus pi over 2 plus 1. If you're not sure, take the 2. Look at my cursor, multiplied by x. Do I get 2x? Yes. 2 times pi over 2 is pi plus 1. Great. Amplitude. The amplitude on this is 1. That's the number in front of the s in secant. And it's, for the scaffold anyways. The period in this case is pi. I had to go 2 pi divided by that b term, which is 2. The horizontal shift is pi over 2, and I'm going left in this case, the opposite of positive. And the vertical shift is positive 1. All right. So let's establish my midline. Boom, right there. Let's establish the amplitude. Here's the maximum line. Here's the minimum line for the scaffold. All right. Now I'm going to shift pi over 2, which is 1 box. So I'm going to start right here. Okay. Now, in starting there, my period is pi. And if you remember, pi is 2 boxes. So I'm going to go right to here. Okay, so I got to fit a lot in that little space. And cosine. Cosine starts at its max, ends at its max. So I'm going to go max, mid, bottom, back to the mid, up to the max. So it's looking like this, okay? And at the midlines, which is really tough to get in there, at the midlines, I'm putting those asymptotes. And now I'm going to go ahead and do the parabola right down there. Okay? Again, it goes on and on. You'd have more as you went, more on top and bottom, but I'm just doing the one right there. And again, I'm just teaching you basic drawings of this, okay? The detailed stuff would have to be done in class as a group, in my opinion. Okay, but this is a great tutorial just to get you through some of the basics. Okay, next one. I'm going to clear this so I have enough room here, okay? So if you need to stop it, go ahead at this point. All right. So the next one we got, I'm going to have to rework this, -2 cotangent. What do we got here? 1/2 x minus pi minus 1. Is that correct? Let's double check like we always do. 1/2 times x is x over 2. 1/2 times pi is pi over 2. We got it. Okay. Amplitude on cotangent, we don't talk about that. There is none. The period on this is going to be 2 pi. How did I get that? Remember, cotangent has a period of pi normally. I'm going to divide that by 1/2. I'm going to get 2 pi. Awesome. The horizontal shift on this will be pi to the right, and the vertical shift will be +1. Okay. I'm sorry. Will be -1. -1. My bad. So start right there. -1. All right. So now I'm going to shift this thing pi, which is 2 boxes to the right. And now I'm going to continue with my period, which is 4 pi, which is 2 pi, which is 4 boxes. 1, 2, 3, 4. There's my endpoint, middle. Fine. Okay. Okay. So what I'm going to do is, hold on a second, scratch that thought. Let me redo that. I may be confusing you on this. Let's try that again here. Okay. Okay. So we're going to start at shift is pi right there. Okay. So this is the starting point right there. There we go. And remember on this, the period's 2 pi, which is 4 boxes. So I'm going to go 2 boxes on each side. And there is my period of 2 pi for this. And if I want to go another one, I'll go to the left. 1, 2, 3, 4. Here's another one. I'll put a point in the middle. Great. Okay, now negative cotangent. Okay, negative cotangent is going to be up on the right, down on the left. Okay, there you go. Last one of the day, and I'm going to erase this in a second here, so make sure you get that dialed in, okay? Last one of the chapter, actually. So pause this if you need to. Last one of the chapter, okay? All right, we got secant. So you're thinking sine, and it's positive. So this is going to be our shape, right? With the midline right there, okay? So I'm going to rewrite this. 2 cosecant 1/2 x minus 2 pi minus 2. If you're not sure you got it, go 1/2 times x, which is x over 2. You got it. 1/2 times 2 pi, which is pi. Great. Okay. So the amplitude on this, one is 2 for the scaffold anyways. Okay. That number is this one right here. Okay. The period on this is going to be 4 pi. That's going to be, that is 2 pi way over here to my left divided by 1/2. That's how I got that period. The horizontal shift is going to be 2 pi to the right. Now 2 pi is to the right is going to be a massive shift. That thing is going to be 8 boxes. I'm sorry. It's going to be 2 pi is 4 boxes. Okay, 2 pi is 4 boxes. So what I may end up doing is I may end up starting this in a, I might move the axis, okay, which would probably be a smart move for me, okay. And then the vertical shift will be we're going -2 down 2, okay. All right. So the first thing I want to do is let me go ahead and move the y-axis. All right. So I'm going to get a nice black line here. I am going to move the y-axis right here. Okay. So you might want to think of that as the new origin is right here. Okay. All right. Because I'm doing so much shifting to the right, I want to make sure I get this dialed in. Okay. So what I'm going to do then is I'm going to let me draw my sine curve. And the period's 4 pi. If 2 pi is 4 boxes, 4 pi is 8 boxes. Wow. So 1, 2, 3, 4, 5, 6. All right. No. 1, 2, 3, 4, 5, 6. 2, 4, 6, 8. Yeah. Okay. There we go. So, all right. So these are going to be my 5 points I'm going to be drawing. I'm sorry I didn't get the amplitude and the vertical shift and the amplitude. So the vertical shift, we're starting down here at -2. Okay. And then I'm going to be getting the amplitude of 2, which goes to that line and goes down to here. Okay, so it's a little bit crazy. All right, fine. This crazy problem is probably a little bit heavy for a test, but that's okay. All right, so I'm going to draw this right here that I'm circling, okay, as my scaffold. Start at the midline, go to the max, down to the midline, to the minimum, and up to the midline, all right? Okay, now, every time it crosses the midline, that's an asymptote, okay? So, now, the drawing, of course, the 2 parabolas go here and go here, because that's the inverse of the sine. All right. Fantastic. That went pretty good. That is section 4.3 for trigonometry using Mr. Snyder's graphing system. Hope you enjoyed it.